in a moment. I will do that in a second, but I think first there should be some introductions. All right, happy spring, everybody. Yay, all right. My name is Erik Johnson. My personal pronouns are he, him, his, and I am the director of the William M. Starkville Planetarium at Parkland College, and this is the first Prairie Sky show we're offering in the new season. And I'll talk about why there are changes of seasons and so on, and I'll get into some nitty-gritty with all of that. But before I do that, I should also introduce my show producer and co-worker right here, Waylena McCully. She also works at the Starkville Planetarium. She produces lots of amazing graphics for our shows, and she is going to help me with moderating everything. She'll share lots of fun links in the chat, and I hope you folks put comments in the chat as well. It would be great to tell us maybe where you're watching us from, what your favorite planet is, what you're looking forward to seeing tonight, and what you'd like to see tonight. All right, we got our first comment there. Kara says that they're watching from Muhammad. That's cool. All right. We've been doing these shows every other week, and we hope we can start these and having shows in person again in the near future. But for right now, we're glad that you can join us through Zoom in this way. If you're curious about the Zoom background that I have behind me, that's an advertisement for the shows that we're running next week. We are going to be on Zoom here moderating a Kaler science lecture. We've got an engineer from the University of Illinois giving a talk about nuclear fusion, and he seems very eager to share lots of information about nuclear fusion. We may be inviting him back in the near future because he has so much he wants to talk about. All right. Oh, so Kara, is that Kara then? All right, thank you. I could have gone either way. I appreciate that correction on that. Okay, so for these Prairie Skies shows that I run, I tend to run them off of my work computer. And to do that, I use the same planetarium simulation software that I use for my home use and everything, and for what I use for my classes. And so that is called Stellarium. And it is software that you can download and install on your own computers. It doesn't take up that much memory, and I think it's pretty, it's something you can handle from your home, and it's a really cool system to try out. That said, if you can't get it installed, they actually have a web-based version where you can just look at it that way. So there's a lot that you can do from your own home to simulate the sky to help plan for an observing event that you're doing. Okay, so Waylena, I see, has already shared the links, and now I'm going to finally share my screen so you all can see what I'm looking at. I'm going to not optimize screen sharing this time because I'm not planning to share any audio, except for my own voice. All right, so what you're seeing here is the sky and also the ground. This image is an image of the exterior of the planetarium. So this is what you can see over on the west side of Parkland's campus on a lovely sunny day. Waylena, how lovely was that sunny day that you took this photo?
It was spectacular. I actually took several photos and stitched them together to get the highest possible resolution.
Nice.
And
nice.
there was not a cloud. Actually, there was one cloud in the sky, but I took it out. But the wind was perfectly calm. Oh, it was a beautiful day.
Wonderful.
I love thinking of it every time we see this.
Yeah, so you'll see a couple of other Waylena's photos. She has one of those nice 360-degree cameras, and she's produced some images that she's actually put up on the dome in the planetarium, and she's looking forward to sharing lots more of those images in the future when people can join us under the dome again. So this is what things would look like there on a nice sunny day, and if I look up a little high above our Fine and Applied Arts wing, you can actually see the sun right there. I set this up at this time so that you can see how high up the sun gets up in the sky. And this is the sky today. And if you're curious about what direction you're looking at when this is at about noon, we are looking nearly due south right there. I hope you folks can see the S in front of you. And as I said, this is our first spring Prairie Skies show. Maybe you've heard about the equinoxes. We just had the Vernal Equinox in the last week. For us in the northern hemisphere, it's the vernal equinox. For the folks in the southern hemisphere, it's actually their autumnal equinox. So they're actually just beginning fall or autumn down there in the southern hemisphere. Now, why is that the case? Why do we have different seasons than those folks do? Well, it's based on what hemisphere is being favored by the sun. And the exact way that we have that equinox coming on a very certain date is because of a couple of lines. So I'm kind of getting into the nitty-gritty here. If we watch the sun go across the sky, there is a path that we refer to as the ecliptic that you can see right there. And the ecliptic runs through a number of very familiar constellations. And I'm going to show you what those constellations are by taking away the atmosphere. So a little joke that I give for all the kids in the planetarium is I say, well, I'm taking away your air, so you better hold your breath. Here we go. I can't hold it forever, all right? So you see the stars up there now, and I'm now going to, let me see if I can do this correctly. I'm betting that's going to only show one of them, so I need to get this going for everybody. There we go. So now you see the dots connected between the brightest stars right there. And I'm going to give you some names as well as some lovely artwork. So take a look at the ecliptic. It's passing through constellations like Capricornus, Aquarius, Pisces, Aries, Taurus, and not Orion, but behind the dome, you'll actually find Gemini right there, okay? So the sun moves along the constellations of the zodiac. Look at that right there, okay? So that is what's so famous about the ecliptic right there. The sun's path is what tells us what the zodiac is. And now I have another line I'm going to show you in the sky here. This one, it just says equator. If you take Earth's equator and project that out into space, up into the heavens, you'll have what we call the celestial equator. And the exact point where the ecliptic and the equator cross, when the sun reaches that point, that's on the date of the equinox. And the sun does that twice a year, once in March on what we call the vernal equinox, and once in September, what we usually call the autumnal equinox, okay? So since the sun is above the equator right now, that means that the sun is starting to favor the northern hemisphere. So that's us starting to work our way into the summer right now. And for those 6 long months since September, when we had the autumnal equinox, the sun was favoring the southern hemisphere. So now that the northern hemisphere is being more and more favored, we're getting warmer and warmer temperatures going from spring into summer and whatnot, okay? Now let me go ahead and take all of that away. And I'm going to turn this off and this and this. Lots of things to turn off here. Thanks for your patience. Okay. And for us to see the skies, the night skies with the planetarium, I want us to see this from a site where the viewing conditions are going to be a little bit better. As much as we love to share the sky with you under the dome on campus, we know that there's lots of light pollution in Champaign. So we want to go to a place with some fewer lights, okay? Some good options in Champaign County include our many forest preserves. A lot of those are very far away from towns, so you get some really nice dark skies from there. And one really nice example is actually on the northeast portion of the county up at Middle Fork River Forest Preserve. Those folks have such great dark skies that that forest preserve has now been declared as Illinois' first international dark sky park. So if you're looking for a place to see some nice dark skies and don't want to travel too far, that's probably your best bet in this county. All right, so let me show you at least one that's a little bit closer to town, and that is the Cuas Observatory. This is southwest of Champaign. It's not that far from the airport. You can see it from the site there. And this is what it looks like during the day and when all the crops have not started growing yet. You see just little saplings right there. So I assume that you did this roughly around May, this photograph, right, Waylena? Or June? Did I get it? Did I guess right that it was May? Okay, cool. So yeah, not a whole lot of corn popping up right there. You know, what is it, knee high by the 4th of July? Is that how it goes? Or is it 6 feet high by the 4th of July? Oh, I clearly am not.
Knee high, but over the last several decades, it's gotten to where it's much higher.
All I'm doing is proving I'm not a farmer. All right, that's just the way it goes. But at this observatory, the fellows of the Champaign-Urbana Astronomical Society have set up some lovely domes and buildings to house their telescopes, which they happily share with the public during times that the conditions are a little safer. They're actually going to be doing a couple of virtual shows over the course of this year on some of those nights that they normally try to open those doors to the public. But notice that since we're in the middle of farmland, we don't have buildings nor many trees in the way. So when we watch the sun set, we can actually see it hit the horizon really nicely. So the sun's up here. Let's go ahead and go a little later into the day. Obviously, the sun doesn't move across the sky this fast. If you're curious about how fast we're going, you can see this is at about 4 p.m. right there. Okay, that's 5 o'clock. We're coming up on 6. If you're curious about where the sun's setting, here's another cool thing to see with the equinoxes. Notice that the sun set just barely north of west. On the exact dates of the equinoxes, the sun rises due east and sets due west. So you folks might recall this, for those of you when you're driving around, maybe to or from work. If you drive on an east-west street right at sunrise or sunset, it's not a fun thing to do because that sun is right in your face and you can't use your visor to block that light from the sun because it's just right there in front of the cars. I imagine there's probably a fair number of accidents. They probably increase during those times of the equinoxes. It's something you really got to be careful about when driving when the sun's right in your face like that. And that happens on the equinoxes. All right, so let's go ahead and let the sun set. It's just after 7 o'clock now here. So we're actually almost at this very moment. So it looks like this would be about the sky you would see if you were to step outside right now. Notice we don't see anything. Oh, hey, look at that. Over here in the eastern sky, I bet you folks can recognize what you're seeing right there. Let's go ahead and get a closer look at it. I'm sure you folks know what you're seeing right now. Maybe you've seen it over the last couple of days as well. So there we are looking at a rising moon. And this moon, notice that the moon is not fully full yet. You see the right side looks very full, but notice that the left side looks like it's slightly dimmer, slightly darker, and that's because the sun is just barely rising on this part of the moon over here, okay? So even though the moon is very, very close to full, it's not quite full yet. The term that we give for this moon that you're seeing here, we call this a gibbous moon, okay? So you're seeing the moon as a waxing gibbous. But also, did you notice that the moon is actually very, very slowly moving across my image? That's because I'm actually giving this to you right now in real time. Take a look at that right there. If you want to see where it is, here, I'll let it go up a little faster. You can actually see the moon moving across the view of a telescope when you are actually watching it in real time if it's nice and magnified. Okay, so here, I'll actually switch it. I'll click on the moon now. I'm going to do that, and I'm going to show you what the moon looks like at this very second. So now we're at the present moment. So there you see that there. So yeah, the moon is getting very close to full. I believe the full moon is actually going to occur on Sunday evening, okay? And that's very significant because if you've ever looked really closely at various calendars, various religious, i.e. liturgical calendars, that means you know that Easter is coming up. Easter is always set up as the Sunday following the first full moon after the vernal equinox. Okay, so for most Christian denominations, they're going to be celebrating Easter 1 week from Sunday on April 4th because of having that full moon this Sunday. All right, so there you go. Now you can understand why those calendars are set and why Easter Sunday is not the same weekend every single year. It's because the moon's phases don't necessarily hit on the exact same day every single year. What's our first comment in the chat here? Oh, Kara says it's not a golf ball. Yeah, it kind of looks like that, doesn't it? That's a really great point to see. Yeah, with us looking at the moon so close, we see all these little pock marks down here. Not just those big gray regions, we see lots and lots of little craters. Now, those craters are actually small enough that when you look at the moon with your own eyes, you actually can't see those craters. I'm certain I can't see those craters. Usually when I look up at the moon, I can only kind of see the gray splotches. And it's not just because my eyesight's, leaves something to be desired, but it's also because those things are usually pretty small. I say this with certainty because craters got essentially named after people like Galileo were looking at the moon through a telescope 400 years ago, around the time telescopes were first invented. And the term crater just comes from the Latin word meaning bowl. They look like they're bowl-shaped, okay? And it was those craters that helped us understand that the moon was not actually a perfect sphere. It has little dimples on it, kind of like the golf ball, as Kara has described here in the chat. Whereas those gray areas, while they do look kind of round in a lot of places, I mean, look at this, you can see the Sea of Tranquility and the Sea of Serenity up here. And once again, I've forgotten which one is which. Those gray areas, they actually look pretty shallow. And that's what's so wild about these lunar seas that you see here. Once upon a time, they were craters of several billion years ago, but that was when the moon was actually still geologically active, and lava actually seeped up to the surface and filled in those craters. And the lava was made out of a slightly different mineral that's a little darker than the rest of the moon. It's really wild to see the geologic history of the moon that you can see here in this image. All right. Let's go ahead and zoom back out because I've got lots more to talk about, I'm sure. All right, so at this time, I think we're still live here roughly. I'm guessing that if you were to step outside right now, you probably couldn't see stuff like this star right here. That's because my software is trying to amplify the brightnesses to make sure it goes through our streaming setup very nicely. But this definitely would be the first star you see after sunset tonight, okay? And the reason for that is because it is the brightest star in the night sky, okay? It's not the brightest star. We know what that one is. That's the one we see during the day, okay? But let me go ahead and click on this so you can see which one I'm talking about. There you go. This star is called Sirius. I wasn't joking. This star is the brightest. Yeah, bad pun. We've got 50 of them, all right? But yes, there's Sirius. Now, Sirius, let's go ahead and go a little bit later so you can see Sirius with some of the other stars there. Ooh, look at that. All right, so this is the sky at about 8 o'clock. You probably won't see this many stars from where you live, but it's just to give you a good sense of this. And I'm going to show you now the constellation that Sirius is a part of. Look at that right there. What does that look like to you folks now that the dots have been connected in that constellation? Hopefully, maybe you can see a little floppy tail back there. There's some hind legs. There's some forelegs. There's a head. I don't see any floppy ears. You see a stick figure. That's accurate, absolutely. Here, let's go ahead and give you some imaginative artwork to visualize what you're seeing there. Now, hopefully you can see that that was actually a pretty good stick figure representing a doggy, okay? This is a dog that Sirius is a part of. We call this the constellation of the dog. Ellie gave us 3 options right there, fox or baby tiger. Those are good options. But we have traditionally seen this as a dog constellation, and that's why Sirius is often known as the dog star that you're seeing right there. And if you want to know the Latin word for big dog, let me go ahead and give that to you. That's what the official name for this constellation happens to be. It is Canis Major right there. Canis Major is the big dog. And this entire portion of the sky is what astronomers refer to as that constellation. So it doesn't just include the bright stars that are in this stick figure, as Kara said. It includes all these other stars in this area. And anything else that we can find in that part of the sky would happen to be in Canis Major. Waylena, have you ever looked at the star cluster that's in Canis Major? Yeah. Do you remember which what the name of that one was? Is it M41?
I think so. Is it?
Okay. Well, I just got my
It's
interest
35,
piqued.
35 is in Gemini, right?
I think you're right. I think you're right. Well, so anyways, here's an example. I wanted to give you folks an example of an object that you'll find in the constellation of Canis Major. Waylena, did you look at that through a regular telescope or through binoculars when you looked at M41?
At one point I did get to look at it through telescope, but binoculars was all I had to work with for a long time, and so binoculars was definitely how
Okay.
I viewed it most.
Yeah. Well, anyways, folks, there's lots of objects in the sky that might be a little difficult for you to see with your own eyes, but they're really easy to see with a telescope or even just with some binoculars. Waylena is demonstrating with her very easy binoculars to use right there. And the one we're talking about is an object that was seen hundreds of years ago by an astronomer by the name of Charles Messier, or if you want to pronounce his first name in the French that he lived in, Charles Messier. Okay, there you go. That's my attempt at French pronunciation right there. And one of these objects in his catalog, I believe, is M41. We're going to see if it's actually in Canis Major. It is. Look at that, right below Sirius. Apparently, it goes by the name the Little Beehive Cluster. That's because there's another beehive up here in the sky. And maybe I should go to that next after this, because that beehive's a lot better to see. It's a lot bigger and brighter. It's one you can actually see without even using binoculars. But we're going to look at the Little Beehive for right now. And as I said, this is the one that is actually M41. It's the 41st object in Messier's catalog that you see here. So let's go ahead and go into that and see what it looks like. These always are a little bit of a surprise for me because Stellarium usually includes some photographs to represent what these deep sky objects are. And so what you're seeing here is what we call an open star cluster. The reason for the term open star cluster is because we're seeing a grouping of stars that doesn't seem to have much of an organization to it. Plus, these stars don't stay together forever. Stars tend to form in clusters, but over time, millions of years, they'll actually just randomly drift apart. They don't have enough of a gravitational pull on each other to stay together forever in these clusters. And we expect that the sun formed in one of these clusters as well, but since the sun is over 4 billion years old, it's no longer in any cluster like what you see right here. So what's neat is, yeah, we see lots of nice white stars in this cluster and a couple of red stars that are really bright right there. So yeah, just a fun little grouping of stars that you can see right there. And somebody saw this and apparently they were reminded of a hive full of bees. Okay. That's reasonable. Now, if you want to see a bigger beehive, I will go ahead and show you how I find this on my own. But it's going to take a little bit of work for me to get there. So you're going to have to be patient with me because it takes me a couple of minutes to explain how I do this. So going up from Sirius and up to the right, we have probably one of the most famous constellations out there because it's full of bright stars and lots of cool things to look at. For one thing, I see 3 stars in a line right here. I'll go in a little bit closer. You see these 3 bright white or bluish stars right there. And then we see 1, 2, 3, 4 bright stars there, including a nice red star up here. And these stars, well, there's Betelgeuse right there. These stars are in the constellation known as Orion. All right, and so there's Orion right there. Orion represents the hunter, okay? So that belt right there represents Orion's belt. These 2 stars represent his legs, and these 2 stars represent his shoulders, okay? So we've got Orion right there. Canis Major is actually meant to be one of Orion's 2 hunting dogs, as a matter of fact. Okay, if you want to see where his other hunting dog is, we'll go up from Canis Major. There's a bright star up here called Procyon, and that will show you the star that we call, the star of the constellation we call Canis Minor. Let's see if I can bring that up immediately. So there's Procyon right there. Canis Minor, as you can tell, is a much smaller constellation. And I have to say, in terms of stick figures, this one's not very good because it's just a single line, right? So considering that as a little dog, sure, it's smaller, but how are you seeing a dog from that? I really think that one was just put there just to fit a narrative. All right, so that's Canis Minor there. Now, going up from Procyon and Canis Minor, we see two bright stars up here, almost at the exact same brightness. They're a little bit different in color though. But since these two stars were close together and about the same brightness, people have seen them for thousands of years as the twins. Okay, and maybe you remember your zodiac constellations that we were talking about before. And here is the constellation of the twins known as Gemini. So the one on the left is Pollux, and the one on the right is Castor that you can see right there. Now, back over where the moon was, in that constellation, that one is the constellation of the Lion, Leo. The moon is in Leo at this moment. The moon actually runs through the zodiac constellations as well. It stays very close to the ecliptic. In fact, when the moon is on the ecliptic and the moon is in the right phase, you can actually have eclipses. That's what I tell my students to help them remember what the name of the ecliptic is. When the moon is on the ecliptic, you can have eclipses. Okay. Now, for those of you who really know your zodiac constellations very well, maybe you remember the zodiac constellation that resides between Gemini and Leo. And if you don't, you're about to see what it is. So here's this star, and it is in the constellation of Cancer, which is the crab right there. Now, this star is very close to where the Beehive is that I wanted to point out. But before I do that, I'm going to draw a little line for you to see this. Going from this star here, which is called Regulus, back up to Pollux, that is usually how I try to find the Beehive, because it's almost perfectly in line between those two stars. And when you look up at that portion of the sky in the middle of the constellation of the crab, you will find this weird fuzzy spot in the sky. And if you've got relatively dark skies, you should see this spot. You should be able to see it without the use of any form of binoculars or a telescope. And then after you do see it, you definitely want to get some binoculars so that you can see all those bright stars of the Beehive. So let's go ahead, and I'm going to zoom in on that area and see what we can find right there. So we're going in. I need to get my artwork out of the way here, and we'll get that out of the way as well. Oops. I think, let me see here. Not really seeing it too well. I wonder where my picture is for this, but I've probably also zoomed in a little bit too close. So we're going to go ahead and play the cheating game. Yeah, it's right around there. Huh. Ah, there we go. Okay. So that's a lovely picture of the Beehive right there. Like I said, I usually use that when I'm looking up at the full sky between the star Regulus and the star Pollux, and I draw a line and I can find that fuzzy spot. The reason why I have to do it that way is because the stars of Cancer are just not very bright, okay? I have a real tough time being able to see them, okay? Oh no. Well, that's embarrassing. Okay, well, we're gonna do this the other way. We found an alternate Beehive cluster. How about that? How funny. Okay, let's see what's going on here. Ooh, there's a different Beehive. Now, if you're curious about the alternate names that we see here in Stellarium, this Praecipe or manger. Praecipe is just the Latin word meaning manger. And the reason why this area is called the manger is because of these two stars right here in the constellation Cancer. This one's called Asellus Australis, and this one's called Asellus Borealis. Those words mean in Latin the northern and southern donkey. Okay, and so this manger here apparently is a place where they would just go and drink some water. So even though this whole constellation is a big crab, these two stars happen to represent a couple of donkeys. Okay, Asellus Australis and Asellus Borealis, as in the southern donkey and the northern donkey. And they're both drinking some water that turns out to be hundreds of stars in our vicinity. Okay, so yeah, lots of tiny little stories like this all over the sky. And like I said, oh yeah?
Oh, I was gonna say, before we get away from these little open clusters, could you go back to the one in Canis Major? We have a question in the Q&A about the color of the stars in there.
You got it. Yeah, I see that William has a great question here. And William was asking about these red stars. So with these red stars, there's a couple of possibilities for what's going on with them. Okay. You've got some red stars that are red dwarf stars, stars that are actually a little bit smaller than the sun and of course a lot cooler, so they look red. And then you also have red giant stars. Did you see when I had clicked on that star known as Betelgeuse in Orion earlier? That star is a great example of a red giant up there, okay? The one on the left shoulder of Orion. That's a very big star. It's basically larger, or at least as large as, Earth's orbit, okay? So we're talking about something that's probably about 200 million miles in diameter, at least. Whew, humongous. And it's far more likely that the stars that you're seeing there in this little beehive are actually red giant stars, because red dwarf stars are really tough to see. Some of the closest stars that we know about are red dwarf stars, and even though they're extremely close to us, they're so dim you can't actually see them without using a telescope. Okay, it's a real shame like that. So yeah, most of the stars that we see in the sky, you're seeing them definitely because they're close, but even though they're close, they're also much brighter stars than the sun is. So you end up seeing mostly stars that are extremely large or extremely hot, or both. Okay, so yeah, great question there, William. Thank you very much for asking that. So most likely those are red giant stars. Did you have anything you wanted to add to that, Waylena?
Nope, nope. You know me, I love red stars.
Okay. Well, thanks for bringing it to my attention. Yeah, so those are a couple of really nice clusters. I want to show you a couple of other deep sky objects because I love going over deep sky objects in the sky. And right now you see I'm looking at Orion right now. And I want to focus on another one that you can see without actually using binoculars. Right below Orion's belt, there are a couple of bright stars there, and I'm going to zoom in on them. And you're going to see these pictures really quickly. Like I said, this is something you can see without a telescope. And then once you get a telescope, you can just be awash in the beauty and color that you can get from this. I'm going to take away the glare of the stars right there. Look at that. That really helps me out. And this is a picture of the Great Orion Nebula. I've already shown you a couple of Messier objects. That little beehive in Canis Major was M41. The regular beehive was M44. This one is M42. Okay, so hopefully you folks are really checking off your bingo cards, okay, with all of this. All right, so this, I know there's a lot of similar numbers. I doubt that anybody's going to be able to call a bingo on this yet. But this one is M42 right here. And in M42, you see a really bright glare of light right at the center there. And that's because there's a couple of extremely hot, extremely large, extremely bright, and extremely young stars right there. When you look at a nebula, you're looking at a region where you are seeing newborn stars whose light is shining out into the galaxy for roughly the first time. These are stars that are only like a couple million years old at most. And I know I just said a couple of million and you're like, wow, that's really old. But for stars, that's extremely young. Okay. In fact, in this region, not only are those newborn stars, they're shining their light. When they shine that light, they actually push out that gas and dust, and they cause it to collapse sometimes to form new stars. So what's wild is that these hot young stars, they're actually causing star formation to occur within this galaxy. So astronomers love looking at nebulae in order to see areas where new stars are forming at this very moment. Okay, stars do take a while to form, but still, it's great to see them in that progress, in various stages of the progress. Now, You might be wondering where all of this light is coming from. You folks are probably seeing a nice range of colors in the Great Orion Nebula. I see some tinges of red, maybe some tinges of blue, areas where they mix, so you get kind of a purple or violet or a magenta color, and that's a really nice mix of those colors. The blue light that you see there is actually light that's being scattered by the gas and dust that surrounds those stars. And that's just because the stars are giving off mostly bluish light, and blue light also scatters really nicely. For proof of that, just look around tomorrow on a sunny day. If it's sunny then, it probably won't be. But the blue skies that you get are because blue light scatters really nicely compared to other colors of the rainbow. And then as for this red light that you see right there, that's because most of this gas is made out of hydrogen. And when hydrogen gets heated up, when those electrons actually cool back down, they give off a lot of red light. And that's why we see that red light right there. Okay, so that mix is what gives you these beautiful colors you see in the Orion Nebula. And remember, don't just stop with what I'm showing you here. It doesn't take that long for you to go online, maybe do a Google search and look for pictures of some of these objects I'm sharing with you here. One of my favorite websites to look at, and I look at it every day, is Astronomy Picture of the Day. Okay, and if you do a search on there, they have an archive from the last 25 years. It's actually one of the oldest still running websites on the internet. And they do one beautiful picture per day. And I'm sure they've done the Orion Nebula there many times. Okay. All right, let's go ahead and zoom out here. And I'll show you some other neat stuff. Probably need to turn the stars back on. All right. And I will show you another neat group of stars. To get to this one, we're going to draw a line from Orion's belt off to the right. And we are going to go past this neat little V shape right here. That's actually probably the closest star cluster to us. All those stars but one are in that cluster. This is a star cluster called the Hyades. And the constellation they're a part of, well, this V shape is meant to represent the head of this animal. And then if you go up from there, you see a star here representing one horn and another star up here representing another horn. So this constellation, well, that stick figure probably doesn't illustrate it very well for you. So let's go ahead and give you some artwork. So you folks now hopefully can see that I'm trying to show you a bull's head and a bull's horns. And this is the constellation called Taurus. And going back from Taurus, you see this interesting cluster right here. And this is probably the most famous cluster of stars in the sky. You see stars very, very close together right here. And these stars in this cluster are usually called the Seven Sisters. Perhaps you can actually see 7 really bright stars right there. Sometimes people might only see 6 of them when they look with their own eyes. But certainly, once you actually get binoculars or a telescope pointed at it, you see a lot more there. Look at that. Okay, you are seeing hundreds of stars here. There's actually at least 1,500 known stars in this cluster. This is a cluster called the Pleiades, but you can call it the Seven Sisters as well. There's a good spelling for you for the Pleiades. Now, if you're actually a big fan of certain car companies, you are more than welcome to call this star cluster Subaru as well. And that's because the Subaru car company named themselves after the Japanese name for this star cluster right here. Okay. Now, that's just showing you how these stars and these clusters and various objects in the sky go by different names for various star cultures. And with the Pleiades, the Greeks called them the Seven Sisters. That went on to what the Romans called them, and we've stuck with that over many European cultures. But other cultures all around the world have given this star cluster different names. Sometimes they're not 7 sisters. Sometimes they're actually 7 brothers. Okay. They have various origins like that. And actually this software Stellarium can show you a number of those cultural examples. I was showing you here this way where you can change the landscapes. If you go to Starlore, you can see what the names of various stars in the sky and various constellations go by under many different cultures all over the world. It's really fun to dive into the software and see what it has to offer for all those examples right there. Okay, so yeah, Pleiades are a great thing to look at through some binoculars or through a telescope. Telescope actually maybe not so much, because you end up having a view more like this, and it gets a little tough to see all of it at once, because it takes up a pretty wide swath of the sky. It actually is a wider region of the sky than the full moon is. Okay, so that's why I really recommend binoculars are the best example. Although, when you look at this area through a telescope, if you can collect enough of that light, you might see all of this gas and dust that surrounds these stars. That gas and dust is like the nebula you just saw with the Orion Nebula. This is a relatively young cluster, and those stars still have a lot of that gas and dust around them. They're probably not forming new stars anymore by this point, because this cluster is about 100 million years old. But those stars still haven't blown away all of the remaining gas and dust quite yet. All right, let's turn back on the stars. Let's see here. Where do I want to go next? Oh yeah, well, I'm in Taurus. I really should just stay there, shouldn't I? Okay, this is what happens when I kind of do this like jazz. Okay, I say jazz because I don't have a script. All right, well, right above that V shape of the bull's head, there is actually an interesting object moving through the constellation of Taurus at this time. And the way that I can show you that we're moving through it, here's what I'm going to do for you. I'm going to show you the time, and you're going to see how I'm going to subtly change the time from one day to the next. All right, we're going to see how things looked here a couple of days ago. All right, so I'm going to go back to yesterday, and now the day before that. Okay, we've gone back about a week there. Hey, the moon's there. Cool, that's fun. That happens from time to time. Remember, Taurus is a zodiac constellation. Okay, so we are seeing the moon's not the only one moving through there. You see another object moving through that area. There, we're back at today. And that other object that's moving through there, its motion is what led to these objects being called planets. They were seen by ancient astronomers as wandering stars. They didn't know that they were objects that were actually in our solar system, much closer to us than those stars are. And let's go ahead and click on that object and see what it is. For now, you can see the color for yourself, and maybe you'll be able to guess which planet this is before we see it up close. Oh, there's another interesting clue. Notice that we've got two other dots right next to it. Those are actually its two moons. This is a planet that only has two moons. Oh, wow, look at the view. This is probably one of my favorite views of this planet because of the features we're seeing on the surface right there. Well, you see clearly we're looking at an object that looks pretty red, and Ellie has guessed it exactly right. We are looking at the planet Mars. You are seeing the red planet right here. Mars is getting pretty far away from us. It's actually farther from us than it is from the sun, so it's getting noticeably dimmer over time. And I see Waylena has a lovely Mars t-shirt on right there with a kitty cat astronaut. Is that a castronaut? Is that the term for it? Catstronaut? Astrocat? I don't know. I need a technical term for this. So yes, she said she needs more meows. Oh, I'm sorry, Mars. So it's not meows? Okay. But yeah, that is Mars right there. Now, a couple of really cool features to show you on Mars. I'm going to admit these objects you will probably not see through a telescope, but since we've sent so many wonderful space missions to Mars, we've got great pictures of this stuff. And one of them is this humongous feature right here. It looks like Mars has a scar. That's actually a pretty accurate statement for it. This here is a humongous canyon on the planet Mars. It is called Valles Marineris. Okay, and that canyon basically is thousands of miles long. If it were on Earth, it would run from the Pacific coast to the Atlantic coast in the United States. That's how long it is. Okay, it is much, much larger than our Grand Canyon. It's expected that one of the main forces that helped carve out this canyon on Mars is erosion. You've probably heard about people talking about water on Mars, and erosion when Mars actually had water certainly helped widen and deepen this humongous canyon, Valles Marineris. And then up at the top here, let me see if I have this paused. I do. You see three bright little what look like pimples here. Those are actually three volcanoes on Mars in a line. And there's actually an even larger volcano just over there, right where the sun is rising at this moment. What you are seeing there are some of the largest volcanoes in the solar system. And they're actually a lot bigger than even any of our mountains like Mount Everest. The largest volcano known in the solar system is this one right up here. It's called Olympus Mons. Comes from the name Mount Olympus. I think that's pretty appropriate. So yeah, lots of cool features to see there on Mars in this image. All right. Now, some of you might be wondering why Mars looks all reddish like that. Well, the surface is covered with lots of rusty dust, okay? Lots of iron oxides right there. All right, let me go ahead and zoom back out, and we'll go ahead and see what else we have to find out here. All right. So that is the sky that we are seeing tonight, and this is actually just at 8 o'clock. Obviously, yeah, there's a lot more stars there, but this is stuff that's still up here. I know this is a lot of winter sky, but I just love looking at these things so much that I had to share them with you. But you did see where the constellation Leo was. We usually refer to that as more of a spring constellation. I would say it might be a bit hard to look at Leo tonight, considering how bright that moon is shining right through the middle of it. So if you're going to look for Leo, maybe look for it a couple of nights from now. Now, going over to the left, just above the dome over in the northeast, I see probably the most famous group of stars that we usually identify. It's so famous, it's actually on the flag of Alaska, okay? And here, I'll go ahead and connect the dots. Ethan says that castronaut is now an official term. Thank you so much, Ethan. All right. So let me go ahead and connect the dots for this next one. Here we go. Got 4 stars, 5, 6, and 7 right there. So maybe you folks are seeing this in one way or another. Maybe you see, I don't know, a big cleaver. Maybe you see a spoon. Maybe you see a shopping cart. Maybe you see a plow. Maybe you see a wagon. Waylena, what was your favorite way to see this one?
Breakfast.
Breakfast? You see a
Like
frying pan
breakfast.
with some eggs. You ate
Cooking
before
breakfast.
this, so I don't know why you're thinking about food. And you even had dessert. I saw it. That's all right. But anyways, folks, when we look at this in North America, we usually refer to this as the Big Dipper, okay? And that's meant to be this big drinking gourd, okay, that you would use to drink from it. You could see it as a spoon as well. And obviously, the Greeks really didn't see it this way either. And it is often called the wagon or the starry plow as well. It goes by many, many different names. And the ancient Greeks, they saw it in the following way. They saw it like this. They actually saw a few more stars there, and they saw it looking like a humongous bear. Although for some reason they decided to give that bear a really long tail. And I tell you, no bears have tails like that. So I don't know what bears those Greeks were looking at. But that's how they see the Big Dipper. It's actually part of a constellation they refer to as Ursa Major, which you've heard this enough times before. It's just the Latin word meaning big bear. Okay. And what's really nice and useful about the Big Dipper, a big reason why it's on the flag of Alaska, is because the Big Dipper has 2 stars. One of them is Dubhe here. The other one is called Merak. And if you draw a line with those 2 stars right over here, they will help you point to one of the most important stars in the sky. That star right there is famous because of where it is in the sky. Okay, yes, Astro Bears, love it. This star right here is called Polaris, and you see it's actually a part of the Little Bear, and you might also see a Little Dipper right there. But look at where Polaris is. It's over there in the north. And as I go later into the night, we will see stars over in the west setting we will see stars over in the east rising. But look at Polaris. It doesn't look like it's moving at all. It's just stuck there in the sky, almost completely frozen. The reason why is because Polaris is right above Earth's North Pole. If you were standing at the North Pole and you look straight up, you would see Polaris right there. For us in Champaign, we don't see it nearly that high up. We're only at about 40 degrees latitude, so we see Polaris less than halfway up in the sky, about 40 degrees, okay? And so that's why Polaris is so extremely important. It's a great tool for navigation. People can look at Polaris any time of the night and they will know exactly which way north is, and based on how high up it is in the sky, that will tell them where they're at on Earth. So you can use that for yourself if you happen to get lost for some reason. You can use that to help navigate yourself and help figure out where to look. Oh, I see. Nicole has just talked about some Pokemon. Perfect. Excellent. That's a great way to remember it. Yes, this one is Teddy Ursa and this one's Ursa Ring. That's a great point. Okay. I won't get too sidetracked by the Pokemon, but thanks for sharing. Okay, now let's go ahead, and this is actually at about the sky at about midnight. If you're curious about what the sky looks like at about midnight, just ignore that big serpent there. Notice that by this point at night, you see that we've lost most of the bull. Orion's actually below the horizon by now. Orion's right there. You see Gemini's getting really low in the west, but like I said, we're in spring. So you shouldn't expect to see those winter constellations too long. Let's go ahead and go a little bit later now. We're actually starting to see a couple of the stars we'd see in the summertime, including actually, I believe, Waylena's favorite star. Here, I'll wait until the whole constellation comes up before we can bring it up here. So this is the sky at about 4:34. Were any of you folks planning to stay up that late? That's way past your bedtime, young person. Or maybe you're planning to get up that early. All right, I'll be happy to share that with you anyways. So at about 4:30, this entire constellation has come up. All right, so this star right here is a part of the constellation known as Scorpius. Okay, and maybe you can see it. Look at this, the stinger. There's actually two stars right there representing the stinger at the end of the tail, and the tail comes up. This bright red star here is right at the head of the scorpion. Looks like only one of the pedipalps happens, or pincers, happens to be lit up there. And that's just because historically these two stars over here used to be the pincers of the scorpion. But this bright star in Scorpius is actually very close to the ecliptic we've been talking about. And sometimes Mars goes right past that bright star. And since this star is red, some people might want to make a comparison between this star and the planet Mars. So they actually named this star in comparison to Mars. They called it Antares. The reason for the name Antares, well, Mars is the Roman god of war. The Greek name for the god of war, Ares. So Antares, anti-Ares, it's being seen in contrast, in comparison to Ares. But if you want to be a little snarky about it, if you see this star at 4:30 this morning and somebody asks you what the name of that star is, you could just tell them it's not Mars. It's not Mars. There you go. They will not be very happy with you when you say this. But I guess hopefully if you want them to not be too mad at you afterwards, you can just at least make sure to tell them you are talking about the star Antares. And that's what it means. So it's just you being snarky as a way to educate. Isn't that nice? It's what we all hope for. All right. So yeah, Scorpius is coming up right before dawn. And if we go a little bit later here, perhaps we'll start to see our last planets here. This is the sky at 5:41. Notice that we're seeing a little bit of dawn coming up. These might be a bit low to catch at this time, but it's still worth looking for them, especially because I know people love to look for these planets. Perhaps if you look for them in the southeast tomorrow morning, maybe you can catch them right before dawn, but you might just want to wait a little bit longer later into the year to catch them again. They were great last fall and they'll be great again this next fall. So this first one here, the one that's a little bit dimmer and a little bit higher, Let's go ahead and click on it. It's in the constellation Capricornus. So is the other one, actually. And yes, you see it's Saturn. I'm guessing you folks want to look at Saturn, don't you? So let's turn off that lovely sea goat. And let's zoom in on Saturn. Looks like we've got lots of stuff around Saturn. Those are Saturn's largest moons right there. You'll probably see a couple of those moons when you look through a telescope, especially this bright beige one right here. That's the moon Titan. But let's just focus on Saturn right now because, wow, I love looking at those rings every time. Seriously, it's just so amazing to catch those rings.
So dreamy.
Yeah, I know. I get lost in the rings. What can I say? We had a space probe orbiting around Saturn for about 13 years called Cassini, and it has given us so many gorgeous shots of Saturn and its moons. And you should definitely look those sorts of things up. I saw Waylena shared the APOD, the Astronomy Picture of the Day link. If you look up Saturn on there, maybe type in Cassini as well. I'm going to type in Cassini right now. You'll find some pictures that you'll want to throw up on your computer's desktop. I promise you. Okay, so you've got that to look forward to. Let's zoom back out. Let's get that other planet there. Not Earth. I know Earth was in a lot of that shot just now. All right, let's click on this here. And this one is going to be the planet Jupiter. And let's zoom in on Jupiter and see what Jupiter looks like. With Jupiter, you tend to usually only see 4 bright stars, but at least with those bright stars, they're so bright you can easily even see them with binoculars because they're actually technically bright enough to be seen with the naked eye. They're just lost in Jupiter's glare, and they'll be easily caught in a telescope. Galileo saw them through a telescope. That's why these 4 moons are called the Galilean moons. And then when you get a close enough view of Jupiter, you start to see these stripes. Jupiter is covered in clouds, just like Saturn is. They have that striped figure because they rotate so fast and they get so much heat from the interior. The clouds end up forming these neat band structures that we call belts and zones. And then Jupiter shows some other interesting features. Notice this dot right here. Astronomers wanted to be really technical when they gave the name of this dot, so they called it the Great Red Spot. That's exactly what it's called right there. And when people have studied this further, they've become certain that what you're looking at there is basically a hurricane. It is a cyclone storm that has been roiling on Jupiter for at least a century and probably for at least 3 centuries. People have seen this thing for a long, long time. We have no idea when it started. We have no idea when it's going to end, okay? It's got a lot of heat underneath it, okay? And to give you a sense of how big it is, this storm itself is larger than our entire planet. Jupiter's a huge planet, and its storms are bigger, can be bigger than Earth. That's wild to think about, but that's what you're seeing with Jupiter there. All right, I'm gonna go ahead and let the sun come back up because I've been talking already for an hour. You guys just didn't stop me. I guess you were hopefully enjoying it. But let's go ahead and go on to sunrise here. Sky is getting brighter and brighter right there. If you're looking around for Venus or Mercury, you're probably not going to catch them very well tonight. I'm guessing Mercury is coming up right before dawn, and I'm pretty sure Venus is now coming up right after dawn, and it sets right after the sun. Don't look around for Venus. It's so close, it's probably lost in the sun's glare, okay? But this is the sky at about 6:30. Looks like the sun is coming up. Yeah, there's the sun right there. I didn't see Mercury at all. I assume Mercury is probably really close to the sun at this moment. Let's see if we can find it. Okay, that's close enough. I think the big problem with that, I wasn't looking around for it. Yeah. Oof, yeah, that was not one you're going to be catching today, okay? So Mercury was coming up so soon, so quickly compared to the sun that you just weren't going to catch it today. Not going to be worth the trouble. And if you're looking for Venus, yeah, oof, nobody's looking for Venus today. No, not at all. So sorry to disappoint you there. You're going to have to wait a few months to find Venus today. All right, well, folks, you have now seen a couple of the things that we could show you that you'll see tonight. I don't want to spend 3 hours with you because then I'd be able to really show you everything I want to share. But hopefully you at least got a good sampling of what's going on tonight. How did the rust get on Mars? Oh my goodness. Well, think about this with Earth. Earth has plenty of iron just like Mars does, but Earth is not all dried out, okay? And since Mars is now dried out, I think a lot of that oxygen that was in the water actually had to, and some of the oxygen that might have been there, had to go somewhere, and it ended up going into that rust, all right? Waylena, do you have anything that you want to add with that comment there? I'm trying to think of a better answer than what I just offered, but it's really just that you can find iron on all of these worlds. And since Mars used to have water, that water was able to react with that iron that helped cause the rust to form.
Yeah.
Does that sound sufficient?
Yeah, iron and oxygen, so it takes a lot of time.
Okay.
Not that much of it.
All right, I'm gonna actually put Waylena on the spotlight because she made as her background image one of my favorite photographs ever. Okay, this is admittedly a composite image taken from multiple photographs from Cassini, but taken from the nighttime side of Saturn. So the reason why the rings are glowing in such an eerie fashion is because some of the light, as it passes through all the trillions of ice particles in the rings, ends up scattering and hitting the camera right there. Some of that light from the sun scatters through the sun's atmosphere, so you see a ring around Saturn right there as well. And then the glow on Saturn's clouds is because the rings are reflecting light that ends up reflecting off of the nighttime side of Saturn. Just an amazing, beautiful picture. Okay. Oh, well, Ellie, thanks for the kind words. And if you're taking off here, yeah, have a good night. Folks, I'll be happy to answer other questions for you. If you have the questions, feel free to use the chat, or you can use the Q&A. Or if you really want to use your microphones, you can raise your hand and we'll allow you to talk. We'll be happy to do that as well. I suppose while you're on the spotlight, Waylena, you can show off your Mars shirt one more time.
Oh, I took off the spotlight.
Oh, okay. That's fine. Well, while I don't have the spotlight on, I can show you the shirt I'm wearing, which is astronomy related as well. Let me see if I can bring this up here. I got this shirt when 3 years ago, my family and I ended up going to Arizona and we saw Meteor Crater. There you go. Yes, Meteor Crater is awesome. It's a great place to visit. Here. Yes, we're real professional here, both showing off our random astronomy t-shirts.
Eric,
All right.
have you ever noticed how close the meteor hit came to the hitting the visitor center?
Yeah, it's I don't know how they were able to miss that 50,000 years ago.
For anybody that's still on, this is my husband, Jeff.
Yeah.
He's the one who talked about birds last month.
Yes, yes, he was our
Really
bird guy.
awesome bird pictures, yeah.
And if you missed that talk, go to our YouTube channel, which is where we have recordings of all of our shows. And that one was a big hit that night, and it's a big hit ever since that show happened. So you can go and check all those shows. This show is going to be up there as well. And also next week, our last Kaler Science lecture of the academic year is going to be up there. If you folks are looking behind me, you are seeing our advertisement that our marketing department set up for that lecture. It's going to be about the basics of nuclear fusion, and it's going to be a talk given by an engineering professor from the University of Illinois by the name of Daniel Andruchik. Okay, so if you join us next week, 7 p.m. here on Zoom, same URL, in fact. So I guess I can make a reference to same bat time, same bat channel. Those are both accurate. You can join us for that lecture. What's that?
You're not that old.
You know what syndication's about. Reruns happen.
Well, it was before my time.
Exactly. But you watched the show as well, even though it'd been long off the air at that point.
See what
Yeah.
closed captioning said about the meteor.
I see what Nicole had recognized. That's great. All right. And then what else can I say with this? Oh yes, after the show, we will have what we've been doing throughout this, throughout these Zoom shows. After the Kaler Science Lecture, there will be a Prairie Skies Spotlight hosted by Waylena, and it's going to be focusing on galaxies. So she'll give you a tour of the night sky and show you some of her favorite galaxy pictures. And however else you want to, I'm going to leave that up to you and how you're going to display that. Okay. All right. So, any other questions for us, folks?
All right. See you all next week, I hope.
Yeah. Have a wonderful weekend, everybody. All right. We hope to see you then.